Okay, so if you're looking at problem 4 and you're like, the heck is this? This is problem 4. On the actual AP Precalculus exam, free response question 4 is going to give you like these list of like directions that you need to follow. Otherwise, you're not going to get full credit. Like it'll tell you about like domains and stuff like that. Radians, you already know that. But, the main thing here is if you can simplify something that's simplifiable, do it. Like, for example, if you're looking at like log base 2 of 8, you can write this as log base 2 of 2 to the third, which simplifies out to 3 and stuff like that. Okay, so if you can simplify them to whatever you can simplify them to, and you'll be good to go. Okay. Same thing here. If you can combine like terms and make that 5x, if you can combine like terms and make that 5 to the fifth, x to the third, ln of 15 because you multiply the insides, do that. Okay. And so we will have a problem today that it will be a kind of a gross answer that we won't simplify. But again, if it's not a gross answer, try to simplify it because they're going to make you. So here we go. Part 4, question 4, part A gives us f of x and h of x, and they're both gross looking. Actually, f of x is the only one that's gross looking. The function f and h are given by f of x equals tan arc cos, which, by the way, I hate that. I'm going to rewrite it. Inverse cosine, 10 inverse cosine of x. Okay? Sorry, AP. I don't follow your rules. And then there's h of x, a bunch of logs. Solve f of x equals 5 pi for values of x in the domain of f. All right. Okay. So f of x in this case is 5 pi. All right. That's going to equal 10 cos inverse of x. Okay. This is problem numero I. All right. If I want to solve for x, I have to get rid of the inverse cosine, but first I need to divide both sides by 10. 5 pi over 10 is pi over 2, and pi over 2 equals inverse cosine of x. Whoa, 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 buddy, you might be thinking. The heck is all that space for? Well, in order to get rid of inverse cos, I can use regular cos. If the opposite works, then why not? Okay, cos of pi over 2 is what x value is going to happen when I do cosine of pi over 2? Well, 0, of course. So 0 is going to equal x, or x is going to equal 0, which happens to be in my domain. And so I'm in great shape. Problem I solved. Problem double I, which is what I'm called when I'm not wearing my glasses, says h of x equals 3. So 3 double I, 3 equals log, ignore that, log, and you know what? I'm not going to do it. 4 minus x minus log of 1. Fun fact, log of 1 is nothing. Get rid of it. So I have 3 equals log base 10 of 4 minus x. I have to unlock the x. How? Well, you take the base 10 of both sides. And what that does is these guys cross out. You have 10 to the third, which is 1,000, equals 4 minus x. Subtract 4, and let me write it over here. Negative x equals 996, and if negative x equals positive 996, then positive x equals negative 996. That's an extra 9 that's not necessary. Oh boy, I wish they would put that in my paycheck. I'm on fire today. Okay? Part A, uno, dos unos. Oop. Hee. All right. Ugh. Rewrite p of x as a single logarithm base 2 without negative exponents in any part of the expression. All right, well, kind of what you saw in the little directions here, all the logs have the same exact base. Okay, if you add logs of the same base, you multiply the insides. That should be a B to make things easier. Otherwise, it would be a waste. What color am I using? Red. B is going to be log base B of AB. I have 6 of those. And if you subtract logs of the same base, you divide the insides. So it's going to look like this. And if you have a number floating around in front of a log, you can take that number and move it up here and make it an exponent like so. Yeah. So 1, the first thing that I'm going to do is I'm not going to do anything yet, but move that 11 up there. So log base 4 of 2x minus 1 minus log base 4 of 3 plus x to the 11th power plus log base 4 of x to the 7th. These two we're subtracting. So let's do log base 4 of u, 2x minus 1, over u, 3 plus x in parentheses to the 11th. And we're still adding log base 4. Now, when you add two things, you multiply the insides, which is going to put x to the 7th up here in the numerator. So my final answer is going to be log base 4 of x to the 7th, parentheses 2x minus 1, close parentheses, over 3 plus x to the 11th. And I'm not going to simplify that because no one's going to want to simplify that. But that is a single logarithm. Now, what double I is asking for us to do is simplify this guy right here. Whenever you're being asked to simplify, if you see a cosecant, write it like the way it's supposed to be written, 1 over sine x. If you see a squared of a trig thing, try to find its Pythagorean identity. 1 minus cos squared x is the same as sine squared x. So why don't I put that over 1 for funsies? Oh, wait a minute. 2 sine x is on the top and 1 on the bottom? Well, let's cross u out. These 1s are useless, and I'm left with just sine x. So that's how I do that one. Sine x infection. I am on fire today. Ooh. Part C, and the last thing. 3 times 4 to the x in parentheses squared over 2 to the x in parentheses times 2 to the 2x in parentheses. Find x such that r of x is 6. So r of x is 6 is going to equal 3 times. And you know what? I see these bases of 2's. Let's make 4 a base of 2. So that's going to be 2 squared to the x, which is 2 to the 2x, to the second power over 2 to the x, 2 to the 2x. 3 is not going to combine with any of these. 3 is 3. Okay, so 6 is going to equal 3. When I have a parentheses with a power in it taken to another power, we multiply the exponents. So u become 2 to the 4x, 2 to the 4x. When I'm multiplying terms of the same base, I add the exponents. So 1x plus 2x's is 3x's. Ooh, I have 2 to the 4x over 2 to the 3x. When you have terms of the same base and you're dividing the one from the other, you subtract exponents. So 3 has not been bothered with yet. And 4x's minus 3x's is just going to be 2 to the x. Now what I can do is divide both sides by 3. The left side becomes 2, and 2 equals 2 to the x. If only I knew what the exponent was for 2. I do know it's 1. So if you have terms of the same base being equal to each other, set its exponents equal to each other, and 1 will equal x, or x will equal 1 because that's proper. That, ladies and gentlemen, concludes the ultimate GOAT test, ultimate AP Precalculus GOAT Volume 2. It's a lot, but I believe in each and every one of you to do it. So thanks for watching. Hope all of this helps. I love you. and hope this helps. I know I said it twice, but I have to end the video by saying hope this helps. So I hope this helps.